Hello, so I had problem number 9. Part A was to find the relative extrema of f of x, and so so the function is x cubed minus 3x squared plus 2x over 2 to the x minus 20, and you differentiate both the numerator and the denominator so you can use it for the quotient rule, which is low d high minus high d low over low, or over the denominator squared. And so to take the derivative of the numerator, you use the power rule, which is when you take the exponent and push it down to so it becomes a coefficient, and you subtract 1 from the exponent. And you do this 3 times for the numerator, and then for the denominator, you use the exponent rule, which is basically keeping this the same, and then ln of the natural log of the base, which is 2. And so that's how you get 3x squared minus 6x plus 2, and 2 to the x ln of 2. But to differentiate it, you have to use quotient rule, which is what I stated before. And so you leave the denominator the same, and then you multiply that by the derivative of the numerator, and then you subtract it from the numerator times the derivative of the denominator, which is what's over here, and then you divide it by the denominator squared. And so to find the relative extrema, you have to find when the derivative, this function over here, is equal to 0, which is at x equals 0.428 and 1.591. And then you plug it back into the original function, and so f at 0.428 is equal to negative 0.021, and f at 1.591 is equal to 0.023. And to determine whether it's a minimum or a maximum, you could make a sign chart, which indicates that when the derivative is negative, the original function is decreasing, and then at 0.428, the shape or the direction changes, because the derivative becomes positive, and so the original function is beginning to increase. And so 0.428 is a relative minimum, and then at 1.591 is the exact opposite. So the original function goes from increasing to decreasing at 1.591, and so it's a relative maximum. And then to determine the absolute extrema on -5, 1, or on the interval -5, 1, you plug in these points back into the original function, and so the points are -5, 10.516, and f at 1 is equal to 0. And then you also use the critical points from the problem above at x equals 0.428, but you don't use 1.591 because it doesn't fit in the interval. And so f at 0.428 is equal to negative 0.021. And so because f at -5 is the highest y value, and f at 0.428 is the lowest y value, the absolute maximum is at x equals -5, y is equal to 10.516, and the absolute minimum is at x equals 0.428, and at y equals negative 0.021.